Hello dear viewer, today we are looking at this empty aquarium. Well, it won't be empty for long of course. We will see how life develops in this aquarium, seemingly out of nowhere, by a process called ecological succession. And in this very episode we'll see the first signs of life, so stay tuned. I've discussed aquatic succession before on this channel, but here's a very brief explanation. A body of water devoid of any life will quickly find itself being colonized by pioneer species, most likely in the form of microbes such as archaea, bacteria, algae, protists, and eventually even unicellular animals. When these die, they either dissolve in the water or sink to the bottom, adding to the organic matter content in the water, which is usually accelerated by organic matter entering the water from sources like leaves, twigs, insects, and even soil. These dead organisms are mineralized or decomposed by various microbes, releasing inorganic nutrients which can be used by primary producers such as plants and algae to grow. Normally, a cycle forms where increasingly large and complex plants and animals will appear, facilitating even larger plants and animals, while the sediment layer grows, leading to shallow swamp ecosystems. But that is not relevant to our experiment. We've seen aquatic succession happen right before our eyes on this channel before, with this tub of water placed outside. Go watch those videos if you haven't already. They are quite fascinating, if I do say so myself. The experiment we'll be starting today is different though, in a key aspect. It will take place inside. To do this, I'm placing this aquarium on my windowsill and filling it with nothing but tap water, which is something I can do as the tap water in Amsterdam is some of the cleanest and purest there is. No further treatment necessary. The fact that this experiment will take place inside means that there will be some differences. Mainly, the succession will likely happen much slower, as the influx of organic matter will be much lower. There will not be any leaves or twigs falling in, and it can't really be accessed by any animals except some insects, and me. This means that the only sources of organic matter for this body of water will be small insects falling in, and maybe some traces in dust. Well, let the experiment begin. You know what's funny? I like water so much that even an aquarium filled with nothing but tap water is enough to draw my attention for, well, let's just say a certain amount of time. After a day you might think nothing really happened yet, which is kind of true, but there is already a small layer of dust forming on the water's surface. We live in a dusty world after all. At this point I thought it would be nice to have a baseline microscopy session. A bit of a closer look, if you will, which turned out to be a bigger challenge than it should have been. As expected, magnified here 160 times, we see no signs of life, only water and dust. This is pretty much what my life looked like during the start of the experiment. A little over a week since the last update, there was, surprise surprise, more dust. I wanted to let a cover glass float on the surface tension of the water so that we could look at the potential biofilm under the microscope in some weeks. But my hands were a little bit shaky and an attempt to fix my mistake resulted in disaster. Maybe taking shaky hands out of the equation and dropping it directly will work better. I guess not. Just look at them laying there. Maybe some tweezers will work. Wow, look at that. Somewhere in the following days, I'm not sure when because I was gone for some days, a major event happened. The addition of a relatively huge amount of organic matter to the system, in the form of two tiny flies. This was a nice confirmation that organic matter does indeed enter the system. And after only 2 weeks, there should now be enough organic matter present to sustain at least some microbial life. And it is very likely that these dead flies, which were probably still alive when they entered the water, brought with them some microbes. So 2 days later I recovered the cover glass in order to, take a bit of a closer look and, well, Sure enough, we have some microbial life. Here we see one of the very first inhabitants of our new ecosystem, a ciliate. The little dot zooming around just above it is a bacteria. In fact, there's quite a lot of bacteria. Every single little black sausage you see on your screen is a bacteria or an archaea. You can't really tell the difference visually. It looks like they might have already formed a very thin biofilm on the cover glass, something these ciliates might be eating from or even grazing on. This entire string is one bacterial colony. Here are the two cover glasses I dropped in the water a week earlier. I thought it would be interesting to look at these as well, to see if there would be any difference with the one floating on the water surface. So I'll just have to grab the cover glass and get it under the microscope. How hard can it be? Well, my inability to grab the cover glass revealed that there was a very thin biofilm forming on the bottom of the aquarium and presumably the walls as well. This biofilm consists of microbes, mostly bacteria in this case, that grow in a matrix of extracellular compounds they secreted. So it's a mat consisting of microbes, usually various microbes, as well as slimy substances. If you look very closely, you can see that the sliding cover glass left a trail of clean glass as it scraped off the biofilm. Well, it turned out to be really difficult to grab a cover glass. I think this is because capillary action caused a very thin layer of water to exist between the two glass surfaces, pulling them together, and I couldn't get anything in between. In the end, I simply did not manage, but I did manage to stir up quite a bit of biofilm. It was too delicate to grab with tweezers, but I did want to look at it, so I sucked some up. And here it is. I'd say it's pretty much what you'd expect, mostly bacteria and or archaea, as well as a few other microbes and some stuff. There might also be some single-celled algae, which could be the green balls. So that's the biofilm. Of course, I'll put the cover glass back on the water so we can track the succession on it. So, 2 weeks ago our empty aquarium looked like this, and now it looks like this. Visually it is more or less identical, but by now it houses an ecosystem. A very delicate one comprised of only microbial pioneer species, but still a real ecosystem. It only took 2 weeks, just 2 weeks, for the first species to settle in this aquarium filled with just water, which, may I remind you, is located inside. If that isn't pretty cool, I don't know what is. It shows that where there's water, there's life, and indeed that life, finds a way. Of course, you know me, I will not stop after only 2 weeks. This will become a series in which we follow the succession of this aquatic ecosystem. Because you know me, you'll know that this probably will not be a very consistent series, so you'll just have to stay tuned, and if you haven't already, you're going to have to subscribe. Well, that's it for today. Thank you for watching my biofilm.